All right. One of the other big things that we can do is estimate digestibility. And digestibility, whether it's in vivo, meaning in the animal, like an in situ study that we could do with the cannulated females, or in vitro, which we're going to do next week on campus, we are going to take a look at how much goes in. And so it's a pretty straightforward formula. You take a look at how much goes in, how much comes out, and calculate it as a percentage of how much went in. And so we're talking about just how much disappeared in the animal system. So for example, and a lot of times what we're going to do is just dry matter digestibility. What's a rough estimate of how much disappears in that animal? So if we take a look at this example here, we're going to set up that equation just like, okay, so 30 minus 12 divided by 30, and we're going to multiply that times 100. And so in this case, because I didn't calculate this out before, I'm pulling up my calculator right now to do that. And so 30 minus 12 is 18 pounds of dry matter disappeared. So as a percentage of 30 pounds, that is a 60% digestibility. Okay? Dry matter digestibility. Okay? It's pretty straightforward to do. The complexity in digestibility comes from collecting all that data, because you have to measure fecal output, you have to measure individual intake, all of those things. And so it's a very, very time-consuming measure to get to, but we're going to show you a shorter duration this next week. And so just kind of being aware of how that is calculated. Another method of forage quality evaluation, and if I'm dealing with forages that have been analyzed quite a bit in the literature, like alfalfa, timothy, orchard grass, our general pasture grasses we deal with, I will actually pay for, when I do a forage analysis, NIRS, near infrared reflectance spectroscopy. Basically, it's the magic black box that takes a look at the differences in how near infrared light reflects off organic molecules, and it kind of calculates through the absorbance of energy. It's massive predictions, lots of math involved, but what NIRS does is it's able to accurately predict forage composition. It's able to accurately estimate fiber levels, protein levels, digestibility, some of those things. So like I said, if it's a common forage that has some literature behind it and has some data behind it, I will choose NIRS because you pay half the price for a forage analysis and it's really fast. And so it's something that's pretty straightforward. If I was testing loads of hay, this is what I would request from a forage lab, saying, hey, I just need an NIRS forage quality. And they would send you the data, and especially like loads of alfalfa or something like that, there's enough data to have really good equations to predict this composition. Now, if we had some random forage that didn't have a lot of research on it, I'd be more likely to choose the wet chemistry actually doing all the procedures, just because there may not be a strong enough data set to predict that composition. With NIRS, it's only as good as the data sets behind it. The last couple of common measures that we sometimes see for forage quality are some indexes. And an index has a base of 100. So anything above 100 is going to be like high quality or better. And anything below 100 is going to be poorer quality or not as desirable. There's two different ones. We have relative feed value and relative forage quality. And if all things are equal and you're dealing with forages, RFQ is the better value because of how it's calculated. But both of these use the relationship that we were talking about between ADF and digestibility and NDF and forage intake to estimate forage quality. It's an excellent way to rank forages. If you're really quickly looking at, you just want one number to make a decision to buy hay on, these are the numbers I would use. And it's fairly accurate. I actually took classes, and one of my mentors developed the relative forage quality and was working on that and published that when I was in grad school. And it's just a quick, accurate estimate of the quality potential for that forage. Now, we need to talk about some factors that are going to affect forage quality. And so there's a variety of things that can affect quality. We've already alluded to several of these with the plant anatomy and morphology, the species, the cultivars, the maturity of the plant, the leaf to stem ratio, how is it harvested and stored, as well as management factors like fertilization rates. Do we fertilize? Do we not fertilize? Are we adding compost? Are we not? Environmental factors, climate, weather, microclimate, all of that. And so there's a variety of things that can affect forage quality, and we're going to move to another video to take a look at some of those.